Let's explore C++ data types. Data types are fundamental building blocks of C++ programs. We will be discussing the fundamental data types. These include integer types, floating point types, character types, Boolean type, and void type. On the right, there are some examples of C++ data types. An integer, indicated by the keyword int, is assigned the value 25. A floating point number, indicated by the keyword float, is assigned the value 19.99. A double precision floating point number, indicated by the keyword double, is assigned a more precise value of pi. A character, indicated by the keyword char, is assigned the letter a. Finally, a Boolean variable, indicated by the keyword bool, is assigned the value true. Here we will dive into integer data types in C++. Let's start by understanding the different integer types and their ranges. The short data type typically occupies 2 bytes and ranges from -32,768 to +32,767. The int data type usually takes up 4 bytes, covering a range from -2,147,483,648 to +2,147,483,647. The long data type can be either 4 or 8 bytes, with a range similar to int or larger, depending on the system. Lastly, the long data type uses 8 bytes, providing an extensive range from -9,223,372,336,854,775,808 to +9,223,372,336,854,775,807. Keep in mind that the exact sizes may vary by compiler and platform. Let's look at some examples. We can declare a short integer like this: short small number equals 100. Similarly, an int can be declared as int normal number equals 1 million. For a long integer, we use long big number equals 1 billion L, and for a long integer, we declare long very big number equals 9 quintillion LL. We can also declare unsigned variants, which only store positive numbers. For example, unsigned int positive only equals 4 billion U, and unsigned long big positive equals 4 billion UL. Now we will discuss integer type modifiers. Integer types can be further modified using signed and unsigned keywords. Signed can represent both positive and negative values. It is the default behavior. Unsigned can only represent non-negative values, such as 0 and positive values. When using unsigned types, the range starts from 0, the maximum value is doubled, and overflow wraps around to 0. Here's a comparison of signed versus unsigned. A signed int, such as signed int equals -10, can be negative. However, an unsigned int, such as unsigned int equals 10, cannot be negative. Let's look at the range difference. A signed short, such as s equals 32,767, reaches a maximum value. An unsigned short, such as us equals 65,535, can reach a maximum value of twice the signed value. When an overflow occurs, for example, unsigned int x equals 0, then x equals x minus 1, it wraps to 4,294,967,295. In this slide, let's explore floating point data types. We will start with an overview of floating point types. A float typically occupies 4 bytes with a precision of 7 digits, and an approximate range of plus or minus 3.4 times 10 to the power of 38. A double usually takes up 8 bytes, offering 15 digits of precision and a range of plus or minus 1.7 times 10 to the power of 308. The long double can be either 12 or 16 bytes, providing 19 or more digits of precision and a range of plus or minus 1.1 times 10 to the power of 4,932. Floating point types store real numbers with decimal points and can represent very large or very small values using scientific notation. Here are some examples. To declare a float, we use float price equals 19.99f. Note the f suffix. For a double, we can declare double pi equals 3.14159265359, which offers more precision. We can also declare a long double using scientific notation, such as long double big number equals 1.23e plus 100L. Here's a precision comparison. A float A equals 1.00000001f may lose precision, while a double B equals 1.00000000000001 offers better precision. Lastly, here are some special values. Double infinity equals 1.0 divided by 0.0 results in infinity, and double nan equals 0.0 divided by 0.0 results in not a number. Let's explore character data types in C++. Let's begin with an overview of the character types in C++. The char data type typically occupies 1 byte and represents a basic ASCII character. The char_t data type can take up either 2 or 4 bytes and is used for wide characters. Introduced in C++11, char16_ occupies 2 bytes and represents UTF-16 characters. Similarly, also introduced in C++11, char32_ uses 4 bytes and represents UTF-32 characters. Characters are stored as numeric codes. ASCII uses values from 0 to 127 for basic characters, while extended ASCII uses values from 128 to 255. Here are some examples of character types. To declare a char, we use char letter equals a, which stores a single ASCII character. Char digit equals 7 stores a numeric character, and char symbol equals $sign stores a symbol character. We can also find the ASCII value of a character. For example, in ASCII value equals a will assign the value 65 to ASCII value. Conversely, we can convert from an ASCII code to a character using char from code equals 65, which results in the character A. Lastly, here are some examples of wide and Unicode characters. Char_t wide letter equals L followed by omega, represents the Greek omega character. Char16_UTF-16 char equals U followed by pi, represents the UTF-16 pi character, and char32_UTF-32 char equals U followed by a smiley face, represents a UTF-32 emoji. Here we will talk about Boolean data type. The bool type represents logical values such as true or false. Size is 1 byte, though it only needs 1 bit. It is used for conditional statements in logic. Any non-zero value converts to true, while 0 converts to false. Here we have 2 value boxes. The first one shows the value true, and the second one shows the value false. Here are some examples. To declare a Boolean, we can use bool is active equals true, and bool hazer equals false. Comparison operations return Boolean values, so bool is equals 5 equals 5 results in true, and bool is greater equals 5 greater than 10 results in false. We can also perform logical operations on Booleans. Bool and result equals true and in false results in false. Bool or result equals true or false results in true, and bool not result equals true, results in false. In this slide, we will discuss void and auto types. Let's begin with the void type. Void represents the absence of a type. It is used for functions that do not return a value and for generic pointers, also known as void pointers. Now let's look at the auto type, introduced in C++11. Auto automatically deduces the type from the initializer. It is useful for complex type declarations and improves code readability and maintenance. Here are some examples of void. Void print message is a function that returns nothing. Inside the function, it prints hello world to the console. Void pointer generic pointer equals null pointer can point to any data type. Here are some examples of auto. Auto I equals 42 foot results in I being an int. Auto pi equals 3.14159 results in pi being a double. AutoName equals C++ results in name being a constant char pointer. AutoIsReady equals true results in isReady being a bool. It is especially useful with complex types, such as AutoResult equals complex function. Now let's delve into type conversions. Type conversion changes one data type to another. Conversions can be implicit, meaning automatic, or explicit, meaning manual. Keep in mind that data loss may occur if not done carefully. Let's look at implicit and explicit conversions in more detail. Implicit conversion is automatically performed by the compiler. It follows a conversion hierarchy and requires no special syntax. Explicit conversion, on the other hand, is manually specified by the programmer. It uses casting operators and gives more control over the conversion process. Here are some examples of implicit conversions. Int I equals 42, and then double D equals I converts an int to a double safely. Double pi equals 3.14159, and then int I pi equals pi converts a double to an int, which may result in data loss. Char C equals a, and then int ASCII val equals converts a char to an int, resulting in the ASCII value. Now, let's look at explicit conversions, also known as casting. In C-style casting, which should be avoided in modern C++, double price equals 19.99, and then int dollars equals int in parentheses price, is an example of C-style casting. In C++ style casts, int exact equals static cast int price is a safer way to perform explicit conversions, and char letter equals static cast char 65 converts the integer 65 to the character A. Finally, let's explore type modifiers and qualifiers. Type qualifiers modify how variables can be accessed or modified. They provide additional information to the compiler and help prevent programming errors. Let's look at some common qualifiers. The const qualifier means that the value cannot be modified after initialization. The volatile qualifier means that the value may change unexpectedly, such as from hardware or threads. The mutable qualifier means that a value can be modified even in const objects. The static qualifier means that a variable persists across function calls and has a single instance. Here are some examples. Constant max underscore users equals 100 means that the value cannot be changed. Const double pi equals 3.14159 is another example of a constant value. Volatile int sensor value means that the sensor value may change externally. With the mutable qualifier, consider a class user with a private constant ID and a mutable int access count. The access count can change even in constant objects. Static int count equals 0 persists between calls. Let's summarize what we learned about C++ data types. We explored integer types, which are whole numbers without decimals. They come in various sizes such as short, int, and long, and have signed and unsigned variants. For example, int count equals 42. Floating point types are numbers with decimal points, offering different precision levels and supporting scientific notation. For example, double pi equals 3.14159. Character types store single characters, supporting ASCII and Unicode with multiple character encodings. For example, char grade equals a. The Boolean type represents logical true or false values, used in conditional statements and resulting from comparison operations. For example, bool is active equals true. The void type represents the absence of a type, used for functions with no return value and for generic pointers. For example, void print message. We also covered type modifiers like const, volatile, mutable, signed, unsigned, static, register, and extern. For example, const int max equals 100. Remember to choose the right data type for your variables to ensure memory efficiency and program correctness. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.